Now see here, consider the first 100 natural numbers. Always remember, sir, if you understand the question, half of the problem is solved. First thing it is, you need to understand the question. Consider the first 100 natural numbers. He is asking us to consider first 100 natural numbers. Let me put it in a set. 1, 2, 3, 4, 5 and so on up to 98, 99, 100. 98, 99, 100. Input set is to first 100 natural numbers. 1, 2, 3, 4, 5 and so on up to 98, 99, 100. Now there is a condition that is given. How many of them are not divisible by any of 2, 3, 5, 7 and 9? In these numbers, we want the numbers which are not divisible by 2, 3, 5, 7 and 9. Which are not divisible by 2, 3, 5 and 7. Simple thing, assume you are a non-max student. We will go it with a simple counting process. After few numbers, you will understand the process. 1 will divide every number, but 2 will not divide 1. 3 will not divide 1. 1 will divide 3. 3 will not divide 1. 5 will not divide 1. 7 will not divide 1. 9 will not divide 1. So 1 will be there in the answer. 2 is divisible by 2. 3 is divisible by 2. 4 is divisible by 2. 5 is divisible by 2. 6 is divisible by 2. 7 is divisible by 7. 8 is divisible by 2. 9 is divisible by 2. 10 is divisible by 2 and 5. 11 is not divisible. 11 is not divisible. 12 is divisible by 2 and 3. 13 is not divisible. One more number we will take. 14 is divisible by 2 and 7. 15 is divisible by 5 and 3. 16 is divisible by 2. 17 it is. Now if you see 11, 13, 17. 11, 13, 17. What are all these numbers? These are all prime numbers. These are all prime numbers. Take some composite number that comes into your mind. Sir, I am taking 21. It is divisible by 3. Sir, I am taking 25. It is divisible by 5. Sir, I am taking 33. It is divisible by 3. Sir, I am taking 45. It is divisible by 9. Sir, I am taking 95. It is divisible by 5. Sir, I am taking 90. It is divisible by 5. That means 1 and all the prime numbers till 100. 1 and all the prime numbers till 100. Sir, counting it will take some time. It will not take some time. In prime numbers, there is one concept. In prime numbers, there is one concept. From 1 to 100, there are 25 prime numbers. From 1 to 100, there are 25 prime numbers. 25 prime numbers. What are that prime numbers? 2, 3, 5, 7, 11, 13, 17, 19 and so on. And so on. So, from where we should start? 11. That means these 4 should be eliminated. That means out of 25, we should start from 11. That means remaining 21 prime numbers are there. Remaining 21 prime numbers are there. And there is one more number which is neither prime nor composite. That also we need to add 1 plus 21. 1 plus 21. Answer for this question is 22. Answer for this question is 22. I hope the concept it is very much clear, right? Some of the students, what I will do is, out of 100 not divisible by 2, so I will take all odd numbers. Then again, how many are not divisible by 3? I will again take all the multiples of 3. That's a very complicated, lengthy process. I can use Euler theorem, but I don't want to use a heavy formulae based learning, especially non-max students also will watch. Simple observation, right? Input is, again second time I am repeating it, in case if any problem is not clear to you, I would recommend you to watch the video again at a slower speed so that you will understand the hidden concept, right? First what I did, I considered the first 100 natural numbers, 1, 2, 3, 4, 5 and so on up to 100. That is the input present in the question. How many are not divisible by 2, 3, 5, 7 and 9? I want numbers which are not divisible by 2, 3, 5, 7 and 9. For my easy understanding, I started deleting the numbers simple with counting. 1, 2 will not divide 1, 1 will divide 2. So 1 is written, 2 is divisible by 2, 3 is divisible by 3, 4 is divisible by 2, 5 is divisible by 5, 6 is divisible by 2 and 3, 7 is divisible by 7, 8 is divisible by 2, 9 is divisible by 3, 10 is divisible by 5, 11 is not divisible by any of the numbers, 12 is divisible by 2 and 3, 13 is not divisible, 17 is not divisible. Then I started understanding that I am getting all prime numbers from 11, 13, 17, 19. For my own convincing thing, I took some composite numbers to check it out. 90 is divisible by 2, right? 95 is divisible by 5. 77 is divisible by 7. Are you all with me? I am convinced that I am getting all the prime numbers from 11, 13, 17. Till 100 I need to count it. Instead of counting it, in prime number basics, there is a concept. From 1 to 100, there are 25 prime numbers. What are that prime numbers? 2, 3, 5, 7, 11, 13, 17, 19 and so on. 2, 3, it is starting from 11. So these 4 numbers I deleted. That means others it is 11. That means out of 25, 4 numbers are deleted. Remaining 21. Here one number it is there. 1 is neither prime nor composite. 1 plus 21. Total answer for this question is 22. I hope the idea it is very much clear. Very, very good question. Sir, is it an easy question? No, it is a moderate level question. These a little time consuming question. These something which you should not solve it in the first 15 to 20 minutes. Little counting related question it is. This question is based on counting. This question is based on counting. Anything related to counting,